Hello friends, today we'll be talking about permutations and combinations, which is a very important topic for your preparation. It generally involves you will get a lot of questions on these, and it's in your entrance exam, for various competitive exams for class 12. You'll get it in banking exams. You'll get it in your CAT, your IM preparation. All these things would involve a lot of thinking goes into this present topic, and it is widely used across various other topics, and you will keep on getting the understanding which you will have will keep on getting used towards your entire life. As you can see, there's a brief agenda which I've put up here. We'll study about fundamental principles of counting, followed what do you mean by permutations, what is combination, and generally what is the difference between permutation and combination. Just to give you a brief idea, permutations generally all the problem statement which would involve permutation would have arrangement word. It's synonymously used with permutations, and whenever you hear about selection, it would mean combination. Generally the students face a lot of difficulty in understanding whether the question is asking about permutation or whether it is asking about combination. Just keep these keywords in your mind, and it should help you a lot while you solve the problems. Typical type of problems which you encounter during which you'll find these concepts which you learn will get used are like how many ways you can select two kings out of a deck of cards. Remember, a deck of cards contains 52 cards, and the question is asking you how many ways you can select two kings out of those deck of cards. Then there's the second kind of question which these are just an example. Don't take it otherwise that these are only two questions. You can make many questions based on this particular topic. The second question can be something like four digit numbers are there, and which how many four digit numbers can you form where 5 is in thousands place, and the number which is formed are even. So just an example of this 5002. This is a four digit number who has a five who has 5 in the thousands place and 2 here, which makes it this whole number as even. Just to give you an idea how many ways two kings can be selected out of a deck of cards in this particular question, now let me explain you what is the difference between permutation and combination. So let's say you select a card where you get a king. So you have to have two kings out of a deck of 52 cards, right? And these kings can be of either diamond or it can be of heart. So a permutation would mean that in which order have you taken out the card. So basically it can be a permutation would mean that a heart is taken out and the diamond is followed by a heart. This is a different permutation than having a heart and followed by a diamond. While if you take combination, the both are same. Basically both of these two would mean same thing. We don't differentiate between them. So there are two permutations as you can see, right? And as far as only one combination. So this is the difference. Next, what we'll learn is fundamental principle of counting, or it is also known as multiplication principle. It's very simple. At first go, it may seem a bit complex, but it's not at all complex. You will find it very intuitive, as we'll see the example which follows this particular definition, and we'll come back to this definition once we go through the example. Let's say you have so the fundamental principle of counting or multiplication principle says that if there's a task 1 which can be done in m ways, right, and there's a task 2 which can be done in n ways, then task 1 followed by task 2 can be done in m cross n ways. Looks a bit simple. Maybe some of the students may find it complex, but we'll go through the example and it will become clear. Let's take an example. In this example, we are you have to travel from Mumbai to Delhi and Delhi to Kolkata. As you can see, I have denoted few arrows. This arrow states that from Mumbai to Delhi you can travel either by train or by airway. And from Delhi to Kolkata, you can travel by train, or you can travel by air, or you can travel by rail, right? So just having a correspondence with the fundamental principle of counting. The task one in this case is traveling from Mumbai to Delhi. So task one in this case is traveling from Mumbai to Delhi, right? I just use shortcut to Delhi. This is task one. This can be done in two ways, as we can see. One is by traveling by train, and another is traveling by air. Then task two is, what is task two? Come on, think. So task two is traveling from Delhi to Kolkata, which can be, of course, done in three ways: train, either by train, or by air, or by road, right? Road, or you can take it railway. It doesn't matter really. So I will just jot down the ways in which you can travel from Mumbai to Kolkata via Delhi. So Mumbai to Delhi, you can travel by air, and once you reach Delhi, you can either travel by train, you can travel by air, or you can travel by road from Delhi to Kolkata. So all this would be Mumbai to Delhi is all three by air, and Delhi to Kolkata by either train, air, or railways. Correspondingly, if let's say you travel by air, you travel by train from Mumbai to Delhi, then again you can travel by train, air, and railways from Delhi to Kolkata. These are only 6 ways in which you can travel between between Mumbai to Kolkata via Delhi. So, applying fundamental principles of counting, this is 3 ways, okay? And applying fundamental principle of counting, it says that if the task 1 followed by task 2 can be done in 2 cross 3 ways, which is 6. As you can see, 6 ways, and this is what it is. From you can see, this is there. So I hope this clears the definition of fundamental principle of counting. Now let's move to a simple example of permutations. Let's say all of you must have used locks which have numbers in them. So basically it will be something like you have to put some 4 digit, let's say it's a 4 digit lock, you have to put 1 2 3 4. There's a predefined number which opens the lock, otherwise the lock is closed. Now how many types of numbers can be there which can be there for possible key to the lock? So basically, I would just to give you an idea. Let's have this. Okay. So what you can see there are four particular digits which you enter. Now this can be done. This particular things can be filled in 9 ways. How now? No, I'm sorry. It's not 9. It's 10 ways. How does that work? So you can either have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 10 digits, right? This can be filled in 10 ways, and of course you can have a repetition, so you can again fill this by 10 ways. Of course again you can fill this by 10 ways. Of course this again you can fill by 10 ways. So let's see how many ways. It's 10 cross 10 cross 10 cross 10. So the fundamental principle of counting here, it just says task 1 and task 2, but you can have task 3, task 4, and so on and so forth, and correspondingly it will keep on multiplying m into n into k into p, any number of ways in which it can be done. So in this case we have just extended the fundamental principle of counting for the task here is to fill the numbers in all these 4 squares, and this can be done in 10 into 10 into 10 into 10, that is 10 to the power 4 ways. We can have we can have a different question which can be such that instead of we can have that the 4 digits of the keys, none of them should be same. So it should not be something like 1001. This cannot be happen. Let's say we put a restriction that such kind of numbers can be the key to this number lock, right? So in this case, what will happen? In this case, let's say you have put in the first place, you can put any of the 10 numbers. Now once you have used one of the digits from this particular set, that number has to be excluded to be filled in this particular box. In that case, you can just fill it using 9 digits, and taking our argument further, this can be filled in 8 and this can be filled in 7. So basically you have 10 into 9 into 8 into 7 ways in which you can have this 4 digit keys with distinct digits at each of the boxes, right? So this is the number of ways in which you can do it, right? And let's say if so I'm just giving you an example, like permutation. These are all examples of permutation. In the first one, there was no restriction on the number of in the first case, like the 10 to the power 4 ways in which we said all the 4 boxes can have any of the 10 digits. All the 4 boxes can have any of the 10 digits. In the next example which you saw, we have put a restriction that only the first we have put a restriction that none of the boxes should repeat, right? Should have repeat digit. Fine. Third example to it can be of how many 4 digit numbers can you form, right? So basically you have to make make 4 digit numbers. Now basically how would you do it at, right? So again, you can fill this in how many ways? You can fill it in 9 ways. Why? Because if you if out of these 10 digits, if you use 0, then if you put 0 here, then what will happen is something like 0 1 2 3. This is not a 4 digit number, this is a 3 digit number. So therefore you can use 1 to 9. You can just use 1 to 9, a subset, to fill this particular box. And now the rest of the boxes can be filled in 10 and 10 ways. So how many ways you have? You have 9 into 10 into 10 into 10. So just see, with just a little bit of more restrictions here and there, with a little bit of intuitiveness, we have a simple problem. Same problem can be posed in multiple ways, right? Now let's see what do you mean by combination. So let's say you have to select 2 letters out of A, B, C. In this case, if you are looking at permutation, you would have A, B. If you select A and B and you say B and A, both are different. Permutations, different arrangements. Basically, A and B is different from B and A. So this is referring to permutation. But we are not concerned about permutation here. We are more concerned about combination. So in combination, A, B and B, A would refer to same selection, right? So in this case, you can have either A, B, B, C, C, A. All these 3. These are the only 3 ways in which you can select out of these 3 letters. You have to select 2 letters. These are the only 3 ways you can select. So and let's have a different example. Let's have 10 people in a room and they handshake. Now how many? So basically, if there's a person C and D, and C handshakes with D is similar as D handshakes with C. So in this case, we don't differentiate between who's handshaking with whom. So basically, either if you take C is handshaking with D or D is handshaking with C, it doesn't matter. Generally, I will not introduce this notation here. What we mean is NCR. NCR is number of combination of R things taken N at the combination of N things taking R at a time. Let's say you have a circle and you have 7 points here. 1 2 1 2 3 4 5 6 7. How many cards can you draw between the points here? So basically 1 to 3, you can draw a card. Now if you draw a card from 1 to 3 or 3 to 1, it doesn't make sense. It doesn't matter. So while counting the number of ways in which this can be done, it won't matter whether you take you start from 1 and join to 3 or 3 to 1. So this is another example of combination. In the underlying ask is same. Underlying ask is to have a number of ways in which this can be done. But of course, you need to understand here here the order in which you join from 1 to 3 or 3 to 1 doesn't make sense. So in this case, you will treat it as a combination problem, right? Or let's say if you have to select four numbers out of 0 to 9, right? In this case, let's say if you have 0, 1, 2 and 3, you select this thing. Now in permutation it would matter whether you have 0, 1, 2, 3 or 0, 2, 1 and 3. So these are different permutations, while in combination it doesn't matter whether you have 0, 1, 2, 3 or you have 1, 0, 2, 3. Both of these represent same combination, right? These represent same combination, while these are different permutations. I hope to continue this class, but for time being